All right. The definition of a rational expression is a quotient of two polynomials. So we have three examples here. And what we want to do is to find out the restriction on the domain. So if we read here, the caution, when identifying values for which the rational expression is undefined, we need to define anything that makes the denominator 0. So the first one here, if we look at that denominator, what would make that denominator 0? So what I like to do is just set the denominator not equal to 0, and then we just solve it for x. So we subtract 2 from both sides. So we do not want x to be negative 2. The second one, x squared minus 6, we do not want that to equal 0. So we say not 0. And then we solve it for x. So we're going to add 6 to both sides. And then we're going to square root both sides. So we do not want x to be plus or minus the square root of 6. And the last one, we do not want x minus 7 to equal 0. So we solve that. We add 7 to both sides. So these are what make the denominator undefined. So they are what we call our domain restrictions, what x cannot be. Example 1, simplify and then identify any x values for which the expression is undefined. So right now we have a rational expression and we want to simplify it. So we want to first look for common factors. So if we have I'm just going to rewrite this problem again. We have a common factor of 2. So we divide both of them by 2. So this will become a 5 and a 3. Then we have a common factor of x to the 4th. So we divide the numerator by x to the 4th and the denominator by x to the 4th. Now what we're left with is 5x to the 4th over 3 times 1 is 3. The other thing we have to do is identify anything that makes it undefined. So if we look at that denominator, what would make this denominator 0? So we do not want x to be 0. All right, the second example, we have to factor it. So we have to factor the numerator first. So we're going to use our diamond. What are the factors of negative 2 that add to positive 1? And that would be positive 2 and negative 1. So the numerator will be x plus 2 and x minus 1. Then we have our denominator. We again do our diamond. What are the factors of negative 3 that add to positive 2? And that would be positive 3 and negative 1. So we factor first, and then we see if we have any common factors. And we do. The x minus 1 and the x minus 1 are common factors. So we're left with x plus 2 over x plus 3. Now be very careful that you do not cancel the x's. These are a not common factor because this is an addition symbol and not a multiplication symbol. So this is our final answer. And then we want to find out what would make it undefined. So we do the original problem. So what would make this factor undefined? We don't want it to be negative 3. And we look at this denominator here, that factor, we do not want it to be positive 1 because that would make each of those factors 0. So those are our domain restrictions. What do we do when we multiply fractions together? What we do is we multiply across. So we multiply across, so 1 times 2 is 2, and then 4 times 3 is 12, and then we reduce that fraction. So there's a common factor of 2. So we get a 1 and a 6, which is 1/6. We're going to go ahead now move on to multiplying rational expressions. So what you do first is you factor all numerators and denominators, then you divide by any common factors, and then multiply the numerators and multiply the denominators. And then be sure that there are no common factors other than 1. All right, so here's an example. So I'm going to first start with this rational expression. I'm going to simplify it. So I have a common factor of x squared. So I'm going to reduce that by an x squared. So this just becomes an x squared, and that's a 1. So right now I have a 2x squared y to the 5th over 3. Then I go to the second one right here, and I have a common factor of, an x squared. So that becomes a 1 and an x. So we're left with 15 over 8x y squared. Now let's go ahead and see if we can simplify any common factors of the numerator and denominator within the fractions. So if I look at this 15 and this 3, they both have a common factor of 3. So that'll become a 5 and a 1. I have a common factor of an x, so this becomes an x and a 1. I have a common factor of a y squared, so that becomes a y cubed, and a y becomes a 1, so these just become 1. So what's left? I have a 2x y cubed over 1. And then in the second fraction, I have a 5 over, I forgot to do this one here. The 8 and the 2 have a common factor. So that 2 will be gone. And that becomes a 4. So 4. And now we multiply across. So we multiply across, we get 5x y cubed over 4. Now, the other thing we have to do is identify any domain restrictions. What can x not be and what can y not be? So in that denominator, we do not want the x to be 0. We do not want the y to be 0.